All right, so carrying on from where we left yesterday or on the previous video, now we are going to use slope and a point to write an equation. So we introduced yesterday slope-intercept form, which or I'm sorry, well that too, but point-slope form. Point-slope form is again y minus y1 equals m x minus x1. So the values that we'll be putting in, we are going to be putting in a number for y1 and x1. Come on. Oh, hold on. I think it's just a little laggy. It's catching up. It's catching up. Give it a second. You can cheese it while I wait. There it goes. I'll leave it like that. And we're gonna put a number in for m. There you go. So we're not going to touch y, we're not going to touch x, we're not going to touch equal sign or any of that stuff, but we're going to put numbers in for the x1, the y1, and the m. So if you look at example 2 here, example 2a, we have a point, and that point is going to be our x1 and our y1 values, the 1 for x, 1, and the -4 for the y1. And of course, m, -2, that's our slope. That's obviously going to be our m, I mean, as it says. So when I put them in, it's my equation, right? Remember y minus y1 equals m, x minus x1. I'm going to be putting, let's go ahead and put the m in there first, the -2. So obviously take that out, put -2 in. And then my x1 and my y1. Now, my x1 is 1 and my y1 is a -4. But because of the minus sign, in addition to the negative that I've put in, the minus and the negative are actually going to converge to double negative, make it a +4. So ultimately, my equation will be y plus 4 equals -2, and then parentheses x minus 1. You can see that as well already worked out. And b is the same thing. So they also graph it. Yeah, it doesn't say, I mean, it says an instruction here, but not in the title. But anyway, you can see they'll do that with the -8, the 3, and the 1/4 on this one down here. So you can see how they put in the 3 for the y, the -8 for the x, and the 1/4 for the slope. So same thing going on there. You guys can take a look at that. As well as graphing. So just to explain the graphing real quick. So what they're doing is they're just taking the point and the line, or the point and the slope, and just making a line from it. So on A, they're going to start at this point, 1, -4. So that's going to be the very first point they put. So 1, if you follow my mouse here, 1, -4, that's this point right here. So that's the very first point that they plot on the graph. And then they follow the slope. The slope was -2, which as an indicator is -2/1. So rise -2 and run 1. So they do it a little bit differently than I do, but it's still be the same thing. I would go down 2 and right 1. They just do it. They go right 1 first and then down 2, but it's the same thing. But down 2 and right 1 gets your next point, which would be here. And again, down 2 and right 1, put your next point here. And so on and so forth. And you can backtrack it as well by doing the opposite, which would be up 2 and left 1, and plotting these points here and here and so on. So that's how they plot it. They start with the point that is already indicated, right? And then they obviously just use the slope from that point. So kind of like slope-intercept form, but you're not starting on the y-intercept. You're just going to start at that specific point, wherever it is. Yeah, and on this one, you can see, again, they started at -8, 3, and then they followed the slope, which was 1/4, so rising 1 and running 4, and it puts you here, rising 1 and running 4. It gets another point right there. So that's how they graph that one. All right. So this one says write an equation of each line shown at the right in slope-intercept form. All right. So I won't overwork this. I mean, if I can see the slope and I can see the y-intercept, then I'm going to do it. So for the red line, I can already see the y-axis here, and I can see it hits the y-axis Yeah, that's 0 at -1, right? So I know for the red line, it has y-intercept of -1. So y-intercept is -1. And if I look carefully at the slope, I can see if I start at -1, if I trace myself up to this, I would be rising 2 and running 1 to get to this next point. And then just to confirm it, I do it one more time. Rising 2 and running 1, I get to the next point. So it seems to me that my rise and run is rising 2, running 1, which indicates to me that my slope is 2. So if my slope is 2 and my y-intercept is -1, this would be y equals 2x minus 1. Now let's try it for the blue line. For the blue line, again, we actually see it has the same y-intercept that also intercepts the y-axis at -1. So y-intercept, I'm going to go ahead and indicate that at -1. Now for slope, we're really going to have to count this out or use the slope formula. So for me, I'm going to count it out. It looks as if we need to go down 2 and then to the right, let's see, 1, 2, 3, 4, 5. So that was down 2 and right 5 gets you to the next point. So down 2 and right 5 is my rise and my run. -2 over 5. So that must be my slope. So in this case, it'd be y equals -2 over 5x minus 1 for my slope and my y-intercepts. And those would be the equations for whatever question number that was. Question 4. Question 5, write an equation of a line that passes through the points in the table. Okay, so this is a very common type of question. And one that I would put a star next to or something. I really want to make sure we can do this because you're going to be asked this particular question probably a lot, probably on a skill check, probably on the test, so and the quiz and so on. So what I want to do is I want to first find the slope. So I can take any 2 points here. So 0, 2 or 2, 6, 4, 10, 6, 14. Any of these 2 points, I'm going to pick the 2 smallest numbered ones. So 0, 2 and 2, 6. So I'm going to take those points, 0, 2 and 2, 6. And I'm going to use my slope formula, x1, y1, x2, y2. And so my formula, remember, was y2 minus y1 over x2 minus x1. So y2 minus y1 would be 6 minus 2. And my x2 minus x1 would be 2 minus 0. So 6 minus 2 is 4, and 2 minus 0 is 2. So I have 4 over 2, which is 2. So this is my slope. So now that I have my slope, I'm going to take a point and use my point slope form. So remember point slope form, y minus y1 equals m x minus x1. Well, I already know m. M is 2, as you can see from what we just calculated on the slope. Slope is 2. That's m. M is 2. So I go ahead and put that in. Now I just need to change out x1 and y1. So I can use any of these points. It doesn't matter. Let's use the 2, 6 point. So 2 is the x value and 6 is the y. So I'm going to put 2 for the x1 and 6 for the y1. And there you go. There's your equation. Now, if you want to simplify this into slope-intercept form, so this is fine. This is a good equation. But if you want to make it slope-intercept form, you'll have to distribute the 2, which would make this 2x minus 4. And then add the 6 to that side. And if you did that, then you'll have slope-intercept form, which will be 2x, see, -4 plus 6, that's going to be 2. So 2x plus 2. So this also works. So the first one we wrote was point slope form, which is a perfectly valid answer. And the second one we wrote was slope-intercept form. Again, a perfectly valid answer. So sometimes you want to read the question to see if it tells you which form to put it in. But as you can see in this question, it says write an equation of the line that passes through the points in the table. It doesn't specify that it needs to be a point slope equation or a slope intercept equation. So if it doesn't specify, then technically either one of these is good. But I wanted to put them both up there just to give you a more thorough answer potentially. All right. This one says identify the intercepts. So let's graph this and identify the intercepts. So I'm going to go ahead and put my coordinate plane on here. Let's do it down here. I'm going to make it kind of there. No, hold on. Let me reverse this because so let me actually go ahead and point out something. So my point first off. So my point is going to be at a -3 for y, -4 for x. So -4x, -3y. Yeah. So I'm just trying to use that before I make my axis. So let's make it as simple as possible. Give us as much room as possible. I'm going to put the y-axis all the way at this end and the x-axis all the way on this end. So we're kind of like looking at the bottom left quadrant of the graph. Normally I make a graph like this for x and y. Well, essentially we're looking at just this portion of it down here. Because I'm going to, obviously you can see I've got -4, -3. So I'm going to plot those points. So -4, -3 ends up putting us here. Starting to think I should change this actually. Yeah, I'm going to move this now. Let's fix this. I'm going to put the y-axis a little bit more in the center. We're going to put the y-axis right here. Okay. I'm kind of fiddling around with this as we go, just so I can make the best graph possible. So -4, -3 will be right here. -4 on the axis here, -3 goes down 3, so there. And then our slope is 1/4. So I'm going to have to go up 1 from here, up 1 and over 4, which puts us right there. I have to do it again, up 1 and over 4, which puts us right there. Now I have to keep going, although I don't really have the room for it, which is why I was struggling before. But I'm gonna have to extend this. I'm gonna have to go up 1 and over 4 again. So if I go up 1 and over 4 again, that'll put me right here. And the reason I needed that is because I need to know both the x and y intercepts. So my y-intercept, as you can see, let's indicate a color here. My y-intercept is at -2. And my x-intercept, let's count this, is at 1, 2, 3, 4, 5, 6, 7, 8. X-intercept is at x equals 8. So identify the intercepts. I've got the y-intercept and I've got the x-intercept. I had to extend out the graph a little bit, but it is what it is. All right. So graph the line and then just look at where it crosses the x and y axis because you're going to get questions about that too. All right. So write an equation in point slope form of a line that passes through the given point and has the given slope. Okay, you can do that. So if I write the equation in point slope form first, I have, again, x1, y1. So this would be y plus 1, because remember when I put this -1 in here, it'd be minus a -1, which turns into plus. M is -2, and then it'd be x minus x1, so x minus 3, because you can see the x1 value is 3. So this is my equation. And now I want to graph this line. So 3, -1, slope -2. All right. So x-axis, y-axis. Let's plot our first point. Our first point is going to be at 3, -1, which puts us right here. And then our slope is -2, indicating us rise and run of -2/1. So down 2 and right 1, which puts you right here. Down 2 and right 1 puts us right here. I ran out of room, so I'm going to go backtracking. I'll go up 2 and left 1 just to reverse course and fill this in. So there we go. This is going to be our line. There it is. All done. I don't even think I want to touch this just because of the fractions. So I'll just bypass that one. It's been a long time anyway. We've been working on this for a while. All right, and then the last thing we're going to talk about is domain and range, final page. So domain is our X values, our range is our Y values. All right, this, take a breath for a second. I need to take a breath. Let's just take a minute, okay? We're almost done. We're going to get there. Domain is X values. Range is Y values. Now we're looking at that on a graph, so we have to be very careful. Look at A and look at B. Notice the difference. A has only 4 dots, nothing between them. They're not connected. It's just those 4 dots. Whereas B has 2 dots. However, it is completely connected. Okay. It's going to matter. It's going to make a difference. So our domain is the X values that this graph would interact with. So like, let me put it this way. Imagine you go from this dot and you connect it to the X-axis, right? So boom, right? That's at -3, right? That is part of the domain. This dot, imagine it connects to the X-axis. Well, it already is on the X-axis, so that makes it easier, but that's at -1. So that's a part of the domain. This dot connects at +1. That's part of the domain. And then this one connects at +3. That's part of the domain. And since there's no filler between these points, it's literally just those 4 values for the domain. They're not connected, so nothing in between these values count as a domain. It's literally just those 4 numbers, -3, -1, 1, and 3. In comparison with B, imagine you connect everything to the X-axis. So if I connect this point to the X-axis, I'm at -2. So -2 is part of the domain, but everything, even because it's fully connected, a full line, this goes there, this goes there, this goes there, this goes there. Everything after -2 here, remember this is at -2, everything there is connected. So at -1.9, at -1.8, at -1.7, right? -1.5, all those values are there because it's connected. So it's a non-stop connection. There's always something there, right? All the way until, of course, you get to +3, where it ends. So my domain isn't just specific spots, it's everything in between -2 and +3. So -2 to +3 is my domain. And the way we're going to write that is this. So this says everything from -2 to +3. That's kind of how you can read it. It's X values between -2 and +3. That's how I indicate my domain for this one. All right, contrary, let's go back and let's look at range now for these. So these had 4, again, very specific points. The range is where they're connected on the y-axis. So if I connect these to the y-axis, you'll see this connects at -2. This connects at 0. This connects at +2. And this one connects to the y-axis at 4. So this would be the range, specifically those 4 values. Again, there's nothing connecting them, so there's no values in between these numbers. It's literally just at 2, at 0, at -2, at 0, at 2, and at 4. Just those 4 specific values. Again, on the contrary with this one, look at where we connect to the y's. So we start, the lowest point we get is at -1 here. But because it's a continuous line, all of this, every point here is connecting to the y value, connecting to our range. So at -0.8, at -0.9, at -1/2, you know, we're going all the way to 0 now. So now you can see we're at 0. So look at the y-axis. Remember, we're focusing on this. I've connected everything from -1 to 0. I can keep going. This will connect all the way as well, right? And all this connects, and then this part, this all connects to the y value. There's always a y point here all the way up until I get there at 2. So there's a point connected to the y-axis from everywhere between -1 to +2. So for my range, it's every y value from -1 all the way to +2. All right, that's kind of my visual of it. And that's again because it's all connected, right? Lowest to the highest, -1 is my lowest, +2 is my highest. And because it's all connected, the range streams seamlessly or continuously between -1 to +2. There's no gaps in it. Like this one has gaps, which is why we have gaps in the numbers. We only list the numbers. This one has no gaps in it. So it is a continuous stream from -1 to 2, and that's how we'd write it. And so you can see that, I think, in the solutions here. Yes. So you can see them here. All the answers that we've just wrote. Hopefully it kind of makes sense. You can kind of see their representation of it as well. So if we try a few examples on our own, 14, as you can see, 14's only got the dots, right? So for domain, right? Let's stick to red for domain. For domain, I have values at -2, at -1, 0, 1, and well, that one's off a little bit, but that one's at 2. Right? And for range, we'll have to look at the y-axis. So range, we have it at 0. We have it at 2 twice, because you can see this connects the y-axis at 2 twice, but I don't need to write it twice, just that. And this connects at 4. Again, this one also connects at 4. So just like the 2, that connects twice at 4. So you don't have to repeat it. You don't have to say 4 twice, but it's 4. So the y values, there's only points at a height of 0, 2, and 4. Is basically what we're saying. There's only points at a height of 0, 2, and 4. And there's only x values at, you know, -2, -1, 0, 1, and 2. Let's look at number 15. Number 15 is more continuous. So domain. As you can see again, domain, think of it as how far left to how far right it goes. It is a continuous line, and it goes, this is kind of hard to see because this is 1, so that must mean each of these is a half. Each of these little markers is a half. So this must be -0.5 right here. -0.5 to 1, 1.5 to 2.5. So it's not numbered very well, but if we count it out, that would be -0.5 to 2.5. So from -0.5 all the way to 2.5. Because again, it's a continuous line, no gaps. So it goes from the beginning to the end seamlessly. That's -0.5 to 2.5. All right. And then for range, range is the same thing, but of course, regarding height. So now we're not really looking left and right, we're looking at how high and low it goes. So the lowest point is at -0.5. And our highest point goes up to what looks like 1.5, right? That's 1, so this would be 1.5. So 1.5. And again, use the y values to indicate range and the x values indicate domain. But there you go. That's the answer for 15. And now number 16. So domain. So again, domain, how far left is it to how far right is it? So the furthest left is at 1, and it's continuous until 5. So from 1 to 5 is my domain. And for range, let's look at the heights. So the lowest height is at 0, and the highest height is at 4. So the range, again, because it's a straight continuous, well, not straight, but you know, it's a continuous line. The height goes from 0 to 4. Range. Lowest, 0. Highest is 4, and it's continuous. So hence, that's why we write it this way. All right. I am going to just cut it there. If there's anything more to talk about in class, I'll talk about it in class, but that's the main thing that I wanted to discuss. So that was a lot. I hope that you guys do well. If you have any questions, just let me know. Okay. And I'll see you later. Bye for now.